Hello, today we are going to study various objectives and outcomes of the subject signals and systems. This type of subject is very much important for analyzing various types of signals in real life. So, there are four objectives. First is to introduce the student to various types of signals. So, what are the different types of signals? Study and understanding of representation of signals and system, how to represent a particular signals and how to represent a system or any electrical or electronic system, how we are going to represent that we will study. To learn and understand different transforms for digital signal processing, that means on what type of manipulations, what type of transforms we can perform on any digital signal, that is the third objectives. Fourth is analysis of discrete time signals and systems. So, whenever the signal is discrete in the time domain, then how to analyze that particular signals and systems, that we will study. Now, what are the different outcomes? At the end of this subject, student must be able to demonstrate the ability to represent signals mathematically in continuous time and discrete time and in frequency domain. So, after successful completion of this subject, student must be able to identify what type of signal it is, whether it is continuous signal or it is discrete signal, whether it is in the frequency domain or it is in the time domain. Second outcome is understand the use of numerical method to analyze the digital signal processing. So, to study the digital signal, we have to perform some numerical methods, and these numerical methods are used to analyze these digital signals. Third is understand discrete Fourier transform and its properties. This topic is very important from exam point of view also and from digital signal processing also. Here we are going to study different properties of discrete Fourier transform. Fourth is analyze discrete time system using Laplace transforms and Z transform. And fifth outcome is basic understanding of state space analysis of the system. So, any electrical system or electronic system can be represented by state space diagram, and the internal behavior of any instance or internal behavior of any system at particular instance is maintained by the state. So, this is called as state space analysis or state space diagram or diagram of the system. So, in this subject we are totally studying about digital signals, how to handle digital signals, what are the different mathematical operations we can perform on the digital signals. So, whenever there are signals is nothing but the anything which gives you the information is called as signals. For example, audio which gives you some information, text, that is also the signal because whatever you type that gives you some information. Then image also gives you some information. So, these are all the types of signals, or these are all the things which are used to give you the information. So, in digital signal processing we are going to study how to handle, how to analyze different digital signals. It may be image or it may be audio signal. So, that's all about signals and system objectives and outcomes. The three topics, that is Fourier transform, Z transform and Laplace transform, these are very much similar to your mathematics 3 subject, but rather this subject is the application of M3 we can say, because you will study various methods or you will study only Z transform or Fourier transform in mathematics 3, but here we will study how this concept will be applicable to handle the digital signals. So, thank you for listening.